Today is the start of a new lesson, which is on equation, lesson number 1 and 2. When we're solving an equation, it means that we want to isolate a variable so that you always have like x is equal to a number or an expression. Okay, so let's do a very simple question as a warm-up. Number 1, solve the following by inspection. So by inspection, just by looking at it, on the left side I have x plus 5, and on the right side I have 13. So x must be equal to 8. Okay, now what if we were to solve by isolating the variable using the inverse operation? So what I would like to do is, so let's take a look at method number, the example 2a. So we want to isolate for x. So what we want to do is we're going to move positive 5 to the right side. Every time you move a number or a variable across the equal sign, it becomes the opposite sign. So therefore x is equal to 13 is already on the right side, and positive 5 will now become negative 5. So therefore x is equal to 8. So what about letter D? So it looks like we have two like terms here, 2y and 3y and negative 8. So let's collect the like terms by bringing 3y to the left side, and we're moving negative 8 to the right side. So I have variable on the left and number on the right. So on the left side I have 2y minus 3y, and on the right side I have 8. So 2 minus 3 gives me negative 1y equals 8. Now, but what's in front of y? We don't want anything in front of a variable, negative 1. So we're going to divide both sides by whatever it's in front of y, negative 1. So negative and negative cancels out. So 8 divided by negative 1, y is equal to negative 8. Okay. Now, what about letter I? So in this case, we have a like term of positive 18.3 and 3.9. Those two are numbers. And we have the one with a variable n. So let's collect the like terms by bringing positive 18.3 to the other side. So on the left side, I'm left with 0.8n equals 3.9 minus 18.3. Okay, opposite every time you move. So 0.8n, when you subtract, gives you negative 14.4. Now, what's in front of n? 0.8. So we're going to divide both sides by 0.8, cancel and cancel. Therefore, when you divide it, it gives you negative 18. Okay. Now let's try letter H. Now if you look at letter H, we have a like term of 2y, and 8. So I'm going to move my like term positive 2y to the left side. So we have 2y already here, and positive 2y become negative 2y equals 8. So when you have 2y minus 2, it becomes 0. And 0 is equal to 8. But actually, 0 does not equal to 8, right? You need to have a variable. So because this is incorrect, you have to say, therefore, there are no solution to this question. So there's no y value here. Okay. Now, what about the method of formal check, which we call it left side equals right side? So when we solve for number 3, I'm going to move positive 7 to the right side. So I'm collecting the like terms. So it becomes negative 7 now. So negative 2x equals negative 22. and then I'm going to divide both sides by whatever it's in front of x. In this case, -2, so that it cancels out. So x is equal to 11. Now, how do I check if this is correct? Well, what I want you to do is make a table, and this side is left side, and this side is right side. So from the left side of the equation, I have -2x plus 7, and on the right side, I have -15. So what I'm going to do is I'm going to plug in my x into the equation, so which is 11 plus 7. I don't need to plug anything because it's just a number here on the right side. So then you get, -2. So -22 plus 7 will give me -15. So do you notice that left side is exactly the same as the right side? So therefore, you have to say therefore, left side is equal to the right side. So indeed, x is equal to 11. It is a correct solution. Okay. Now what about if you are working with a word problem? So let's take a look. So Colin ordered 3 pizzas. So if he paid $27 for the order, including a delivery cost of $150, how much was each pizza? So your let statement is always based on what the question is asking. Do you see the squiggly line here? So we have to say let how much. So that means let x be the cost of each pizza. Okay, pretty much whatever the question is asking, that is the let statement. So then let's write the equation. So he ordered 3 pizza, 3 depending on the price, so it's 3p plus one-time delivery fee, $150, is equal to the total cost. Right now we do know the total cost, which is $27. So after we set up the equation, I'm going to move positive 1.5 to the right side. So I'm collecting the like terms. So 3p is equal to 25.50. And then I'm going to divide both sides by 3 so that it cancels out. So p is equal to 850. So therefore, because it's a word problem, each pizza is $8.50. Don't forget the units, okay? And that's how you summarize the problem. Now for what about for lesson number 2, we're going to concentrate a little bit more on solving a multi-step equation. So it may not be just one step, but you may have to move around a couple more times. Okay, so let's take a look at number 1. So solve, so in this case, we have 5x and 2x as a like term. We have -6 and +8 as a like term. So I'm going to move variable on the left side and a number on the right side. So on the left side, I already have 5x, and +2x now becomes -2x. And on the right side, I already have 8, and -6 will now become +6. So collect the like terms. 3x equals 14. Whatever it's in front of x, we divide that by that number. So x is equal to, so in this case, it's gonna give you a decimal number. So we will leave it in a fraction, in exact. So in order to check, again, make a left side equals right side table. So on the left side, I have 5x minus 6, and on the right side, I have 2x plus 8. Now I'm going to plug in a number, which is, in this case, x is 14 over 3 minus 6. And on this side, I'm going to plug in 14 over 3 with 2. And when you multiply, it's going to give me 5 times 14 is 70 over 1, because there's invisible run, right? So 1 times 3 is 3 minus 6. Again, 2 is actually 2 over 1. So 2 times 14 is 28 over 3 plus 8. And when you simplify this, by finding the common denominator, you're going to get 52 over 3. And this one also make a same denominator of 3, so you'll get 52 over 3. So therefore, you could say left side is equal to the right side. So your solution is correct. Okay, what about number 2C? So this time we have a brackets. So before you move anything around, you want to make sure you open up the bracket first and then move around. So in this case, it looks like from this bracket, we have -3 in front of this house. So I will be multiplying -3 to 5t and -12, distributive property. And what's in front of this bracket? There's invisible -1. So I will be multiplying -1 with 20t and +1. Okay, so therefore we write 14 is equal minus, so -3 times 5t is 15t, -3 times -12, so negative becomes positive, 36 equals 1 just comes down, -1 times 20t, -20t, and minus 1. Now let's simplify on the left side. It looks like I have 14 and 36 here, so -15 plus 50, and 1 minus 1 is just 0, so -20t. So collect the like terms. I'm going to move, let's say, -15t to this side. Okay, so when I do that, I have 50 is equal to -20t plus 15t. So 50 is equal to -5t. Now what's in front of t? -5. So let's divide both sides by -5. Cancel. So 50 divided by -5, t is equal to -10. Okay. Now, example 3 is a little bit different. It's same idea, but we are looking for a value of x and state any angle properties used in your solution. So in this case, it looks like we're given a isosceles triangle, and to look for x, we have to set up an equation. So we do know that if it's an isosceles, so this angle must be same as this angle. So this must be x plus 5 due to isosceles properties. Okay, and then to set up another equation, we know that the three angles, the sum of triangle is equal to 180. Okay, so sum of triangle is 180. So therefore, 180 is equal to angle, the first one, 3x plus 10 plus x plus 5 plus another x plus 5. So when we're adding, you can just get rid of the brackets. Okay, so just get rid of the brackets because it doesn't really, nothing is in front of x, so no distributive property. So instead, we are going to collect the like terms. X and x, 10, 5, and 5. So therefore, on my right side, 3 plus 1 will give me 5x. And then 10 plus 5 will give me 20. And now I'm going to move 20 to the left side. So it becomes 180 minus 20 equals 5x. So therefore, 160 equals 5x. Now what's in front of x? 5 and 5, so that we can cancel completely. So x is equal to 160 divided by 5 will give me 32. So therefore, x is equal to 32. Now let's do the last question. Example 4. So 5 more than double a number is the same as 10 less than the triple the number. Okay, so determine the number by first writing an equation and then solving it. Okay, so first we could say let x be the unknown number. Now let's do the first part. It says 5 more than double the number. Double a number means 2x, and 5 more, so it's plus 5, is same, so same means equal sign. 10 less than the triple the number, so triple the number is 3x, and then 10 less, so minus 10. So now that we have the equation, let's move, collect the like terms. So I could bring 3x to the left side, and I could bring positive 5 to the right side. So on the left side I have 2x minus 3x. On the right side I have negative 10 minus 5, opposite sign. So negative x equals negative 15. So we're going to divide both sides by negative 1, so it cancels out. So therefore, x is equal to negative negative becomes positive. So x is equal to 15.